thanks for checking out Chemistry Connections on the Hopewell Valley Student Podcasting Network, a proud partner of hvspn.com, where students come together to publish content to share with the world. The opinions represented within this episode are those of the content creators only. Please enjoy the show.
Welcome to Chemistry Connections. My name is Scott Hunt, and I am your host for episode 9 called Blue Light. Today, I will be discussing how blue light affects your eyes. A little bit of background information to start. Your eyeball, imagine a circle with the outside world to the left and your brain to the right. All the way to the left, the cornea, which is a transparent outside your eye to help protect the eye, let light through. And the next is your pupil and the iris. The pupil is the black part of your eye, and the iris is the colored part of the eye. Directly behind the iris and pupil is the lens. Then all the way to the right, on the very back of the eye, there is a light-sensitive tissue that when light hits it, sends signals to the brain. In the retina, the tissue on the back of your eye, there are photoreceptor cells. So in those cells require molecules called retinol in order to sense light and trigger those signals that get sent to your brain and help you see. Light is electromagnetic radiation that travels in waves as a form of energy, so it has energy values. The different color of light is due to the different wavelengths and frequencies that light travels at. Short wavelengths have higher frequencies and have more energy. For example, X-rays have even shorter wavelengths than the visible light, and because they have more energy, they're more dangerous, which is why we need to wear lead when we're getting X-rays, and that we don't want to get X-rays all the time. And UV rays are also more dangerous rays, but they don't have as short as wavelengths as X-rays do. So blue light is at the very top of the spectrum of the visible light spectrum. So a lot of spectrums, but basically blue light has the shortest wavelengths of the visible light that we see and use. There's natural blue light, which comes from the sun, and that light is what we use every day and isn't. We get very little direct contact with the natural blue light, so it's not harmful in any way, and that is why the sky is blue, actually. Fun fact, though that blue light bounces off the air molecules, and bada bing, bada boom, blue skies. Next is more of a chemistry in-depth topic. It's called excitation, and it is when basically light gets sent into a molecule and it causes electrons in the molecule to be pushed into an excited state, which means the electron moves to a higher energy level, causing the molecule to change. And when that happens, a result can be a reaction. Moving forward, basically, blue light, when exposed to the retinal, can cause the molecules to go through excitation. Basically, the energy from the light causes the molecules to go through excitation, pushing the electrons out into a higher energy level. When that happens, a reaction happens which forms a non-degradable material known as lipofuscin, which is basically toxic and poisonous to the eye. And another byproduct is retinal condensation products. But basically, the lipofuscins that scientists have found basically is toxic and damages and is poisonous to the retina and retinal molecules, and basically kills off the photoreceptor cells and harms your eye. And basically too much of this blue light will eventually lead to the disintegration of the cells in your retina, so you basically can't see anymore, which causes blindness. Well, this tends to happen in later, when you're 50 or 60, scientists have been able to see. And this is only caused by blue light, scientists have found. And the retinal molecules do not create the lipofuscin toxic material itself, and the blue light on other molecules do not make the toxic material. It is only when blue light and the retinal molecules interact is when the toxic poisonous material is formed, and That's basically it. And that is only due because the blue light has the shortest wavelengths and the highest energy of the visible light spectrum, that it is able to penetrate through the cornea and the lens to go straight into the back of the eye. And that's basically why the amount of energy is present at the retina for the molecules. Blue light has first wavelengths, but it's like 400 to 450 nanometers. Basically, this is important because, first of all, we see blue light every day, and we are on technology and on our phones constantly, all the time. And it's good to know, phone manufacturers and computer manufacturers are making blue light filters, so phones and computers give off less blue light, which is good. But I use my phone a lot. I'm looking at a computer right now recording this, and it's important to understand why everybody is like, don't look at your screen time all the time, because it does hurt your eyes. But there's more and more things that we can help prevent the loss of our vision. Basically, there's glasses that have blue light filters. There's the blue light modes, the nighttime mode when you hit 8 o'clock and then your phone screen goes orange. That's because your phone is giving off less blue light, so you see orange, basically, or however intense you make it. And that's basically it. So, thank you for listening to this episode of Chemistry Connections. For more student-ran podcasts and digital content, make sure you visit www.hvspn.com. Thank you.